Right, we are now set up. Thank you, Fergus. Thank you everyone for accepting my talk at SAFNOG. It's always a pleasure to come to SAFNOG and to Cape Town, where I left a piece of my heart. I actually did my PhD at UCT a few years back. So glad to be here, and glad to see all of you after a couple of years. It feels like it's my first time again. So I'm going to talk about RPKI, which is quite in the trends nowadays. As you know, RPKI is a security framework added on top of BGP. So if you're a network operator, surely you must be using BGP to propagate your routes. As one of the best practices on the internet, we would like routes to be secured, and BGP is one of the techniques that we use to secure to have secure routing. But as everything in life, time is the essence. Time is money, and you would like to know how much time it takes when you do an operation on the RPKI. Whenever you're flying, for example, you want to know how much time it takes. So this is the same thing. Maybe just a bit of background about RPKI. As you know, the way it is currently organized, you have 5 what we call trust anchors. So your RIRs. Your RIR would be one of the trust anchors. So in our case, Afrinic has one of the certificates out of the 5 certificates which are used to maintain RPKI globally. And as a member yourself, you will receive a certificate that you can use to sign what we call Route Origin Authorization Objects, ROAs. So the ROAs are basically an attestation with an AS number. So you're basically allowing that AS number to authorize, to announce your prefix. Just to give you a little bit more details about how these are connected. So you have the topmost certificate authority, which has all the resources. So usually it is handled by the RIR. And then you get yourself a certificate as an LIR. So you have a public key and a private key as well, which you can now use to sign objects, as I mentioned, the ROA objects. And maybe in the future we'll have more objects like ASPA and other types of objects as well. So this is how things are connected. So once you create these ROAs, they need to go somewhere public, right? And this is where they are actually hosted on what we call public repositories. Each RIR, again, has their own public repository where relying parties, these are called validators. We have a few of them. I will mention about them later on. These validators will go and fetch these objects from these repositories and then run some validation, some cryptographic operations to actually validate those objects. And once they have this validated set of objects from the ROAs and everything, they will send this to the router for the router to make the decisions about routing. So on one side, you have what we call the validated ROA payload. So you as an operator, you would create the ROAs saying, okay, this AS number is allowed to announce this prefix. And on the other side, you would have the BGP announcement coming to your router. So putting them together, the router will do the magic, and now we'll do what we call route origin validation. So based on the data that it will get from RPKI, it will now tag the announcement it is getting as a valid announcement, or an unknown announcement, or an invalid announcement. So usually what we tell operators to do is drop the invalid, because thanks to RPKI, we know that this announcement is potentially a hijack. You should drop that invalid. And this is what we call route origin validation. Now the problem is, there might be different scenarios in which you, as an operator, you might face. For example, you might have created a ROA back in the past, and then you forgot about it, and then this ROA has become problematic. You want to remove it. There are cases, for example, if your network is under a hijack, you are being DDoSed. For example, you might be a victim of a hijack. Let's say your /20 is being hijacked by another AS. Normally, what you would do is perhaps to redirect traffic towards your site, you would create more specific announcements, /24s, for example, and then you would like to create a ROA to protect these more specific announcement. So in these cases, you would want traffic to come back to your network rather rapidly, but how much time it will take. And all this depends on the RPKI system, how much time, the propagation time of RPKI system, and at what point in time after creating a ROA or after deleting a ROA, it will impact BGP. So this is what we looked at. So as I mentioned before, that RPKI supply chain is a bit complex. It starts with the RIR portal, where you would connect to your RIR, your favorite RIR being Afrinic or someone else. There you would go and if you have an RPKI engine already, you would create a ROA. The certificate authority will take a bit of time because it has to contact usually hardware security module to fetch the private key, create a sign an object, create that ROA, and then publish it in a publication point. So these are the different steps that add actually processing time to the RPKI supply chain. Then you have the relying parties I mentioned. So these are separate software that would collect this information from the publication point and validate them. So this is also adding some time. And finally, your router, which are connected to the relying party software, they also have their own refresh time, which is also going to add to that chain. So how long does it take between the user query, the time when you click, okay, let me create a ROA on the Afrinic portal, and the time where you will actually see the change in BGP? So as I mentioned, these are the different time elements. First of all, you connect to your portal. You would create a ROA. This is T0. T1 is when the actual ROA is created. T3 when it is published. T4 when the relying party will fetch these objects, and T5 where your router now has a refresh time when it will contact the relying party. So on the internet today, or for RPKI, we have different types of validators. The four of them which I'll mention here, Routinator, Fort, Octo RPKI, and RPKI client are four that are currently being used. Routinator is by far the most popular, so most of the operators that are doing router origin validation are using Validator. And as you see, there are two protocols to actually collect this data from the publication point. There is what we call the RRDP for data protocol and rsync. Nowadays, rsync is less and less used to the favor of RRDP, which is less resource intensive, and also it uses HTTP, so it has the advantage of the HTTP protocol, the caching, all the features, and things like that. On the router as well, so here I've mentioned only 4 routers, but you have so many different routers. They also have their default refresh time, which is, for example, can range from 5 minutes to 15 minutes to an hour. So very different refresh intervals for the routers, and very different refresh intervals for also the validators. So putting them together, you have like an idea of how much time it might take, worst case scenarios, for example. So let's say for the routinator on router OS or FR routing or BERT, it might take an hour, but on FR routing, it might take as as low as 10 minutes as well. So very, very different ranges. So we also had a look at which are the validators which are the most used, and as I mentioned, Routinator is the one that is the most used. And you can see that Routinator has a refresh time of 10 minutes, which is more or less what everyone is kind of relying on those days. So time consideration. So some general consideration that the IETF gave to the relying party software developers is that the RPs must balance the refresh interval, especially if they're using rsync, because the rsync is, as I mentioned, very resource intensive. So on rsync, they shouldn't have a refresh time more than 1 hour, because otherwise, just imagine all I think we have detected more than 2,000 relying parties out in the wild. But if all of them are doing rsync, this will create a lot of burden on the relying parties, so this is not great. That's why it's generally now actually all the validators have switched by default to the Delta protocol, and if the Delta protocol is not available for some reason, let's say the HTTP server is not available, it will fall back immediately on rsync. So we did an experiment to actually see what's going on. So thanks to a policy at Afrinic, so Madhvi talked about policy this morning. There's a policy which allows researchers to get access to internet address space. So thanks to Afrinic, we got a prefix. So we actually two prefixes, one control prefix and one test prefix. So the control prefix, we advertise it using our own ASN, and the test prefix as well, and based on whether or not there is a ROA. So that prefix was at some point reachable and at some other point not reachable. So we advertise our test prefix using two upstream providers. Our upstream providers were NTT and Sprint. And then we create a bad AS, a ROA with a bad AS. For example, here we use AS666 for the prefix B. And at random time, we were creating a new ROA so that when you create a new ROA, allowing our prefix to be valid, so our prefix was seen as valid, so our prefix were reachable on the internet. And when we remove that ROA, because of the bad ROA still there, our prefix were not valid anymore. So this is how we tested reachability. And then on the BGP side, we could actually see the time. So what did we measure? We measured the time difference between the time we created the ROA and the time we see the announcement on BGP. So for this, we were using route collectors. So we use route trace, which are getting their data from so NTT and Sprint, because they are peering with the route collector. So we could see actually our prefix being reachable from route trace. So we took the time difference for both creation and deletion. So this is actually we did, I mentioned about Afrinic, but we did that experiment for all the 5 RIOs, and we actually were grateful, we are grateful to all the RIOs that have actually helped us to get these experimental prefixes to run our exercise. And basically this is the results that we got. So for Afrinic, to create a ROA, it is almost instantaneous, so 0 minute. It takes almost 2 minutes for it to appear on the repository. The relying party software, because they have a refresh time of 10 minutes, so around 10 and 12, around 11 minutes or 12 minutes, they would appear on the relying party. So in the brackets here, it's for IPv6. So we have done the experiment for prefixes, IPv4 prefixes and IPv6 prefixes. And more or less, we have seen that in 15 minutes when we create a ROA, it will appear on BGP, 17 minutes for IPv6 here. So for Afrinic, RIPE, and LACNIC, so the numbers are quite okay, ranging from 15 minutes to 18 minutes, quite okay. For Epinic, it is a bit longer. So it takes more or less 10 minutes longer, and we figured out that's because they have a batch processing process, actually, a batch process that they put in place. So they would collect requests to create ROAs and publish ROAs in 10-minute batches. So that's why we see that offset of 10 minutes for Epinic. Sorry. And we actually found an issue at ARIN. So as you can see here, ARIN has very high delays. Sometimes it would take up to 95 minutes to get a ROA published. And that's because they had an issue on their timing. So because of some daylight saving issue, they were not, when you create a ROA, it was created in the future. And when you have a date on the ROA which is in the future, it will not be considered as valid. And therefore, the ROA will not appear in the repository. So we contacted them and we told them that this is what we are seeing. So you have, when we create a ROA, it doesn't appear in your repository immediately. It takes a few hours. And it could be a problem, especially if someone wants to create a ROA quite in a rush, for example. So after fixing their issue, we have seen that they more or less take 20 minutes for BGP to actually have a change. So that's on the creation side, and we did the same for deletion. So in some cases, you would want to remove your ROA from the repository, and for Afrinic, it takes around 46 minutes. For Epinic, 53 minutes, for ARIN 45 minutes, and for LACNIC 63, and for RIPE 46 minutes. So you see the difference between creation and deletion. Creation, it takes maybe 15 to 20 minutes, but for deletion, it takes much longer. So one of the reasons, maybe you as operators, you could confirm that, is perhaps some of the operators are using multiple relying parties. So the BGP need to wait that all the ROAs are actually removed from all the relying parties to be able to say that, okay, now we will withdraw this message. And the fact that if operators are using multiple relying parties at the same time for load balancing purposes or redundancy, so the deletion can actually take much more time. This is for Afrinic, because if you're interested about the Afrinic case itself, so as I mentioned, it takes more or less 15 minutes for creation and around 45 minutes for deletion. That's it. I just wanted to tell you how much time it takes when you do an operation on RPKI, which I think is becoming more and more important. Yeah, questions?
Thank you, Amreesh. Do we have any questions? Andrew. We have Andrew. Do we have a microphone?
Andrew from Liquid, and also one of the ADs in the IETF. Recently, there was a bit of an issue discovered with root origin validation on routers that were not doing what's called full adjacency rib-in. Effectively, you've got an invalid route that's arrived because of an invalid ROA, and then a ROA arrives that validates the route, and the router sends an entire route refresh the moment it gets that. This causes mass spamming of route refresh requests. And Mark Tinker over here, as well as Randy Bush and some others, have put out an RFC that effectively says that if your router can't do full adjacency rib-in, which in Cisco terms soft reconfig inbound, or a selective version of this to hold those dropped routes so that you can avoid the route refresh, you should turn off ROV because it's, well, bad for things. Now, when we look at speeding up the times, etc., for creation, that could also potentially end up in even more refreshes. So my question to you and the room is, when people are faced with a choice of either potentially replace equipment to make this work or turn off root origin validation, which way are providers going to go? And I'm quite curious to kind of get a gauge from the room on this, and I spoke to Mark before I asked this question, and he said he'd be interested in hearing the answer to this as well, because it is a problem at the moment. And the other question is, should a behavior of do not run this, if you cannot support the full adjacency rib, be a must, or should there be an exception in there that says, well, consenting adults, peers can agree between them to violate this and run it anyway and put up with the refreshes? Because that's something that I've been struggling with and negotiating wording on, because the current draft that fixes this explicitly states that you must not do this, and I'm like, well, consenting adults, people can agree, and there's been some debate about it. So I'm just curious to get your thoughts and also the thoughts on the rooms, because it is something that I'm still debating in my head very much. And I know that I think Ben had his hand up there, so he can kick off.
Should we let Amreesh give a quick response and then we'll work the room?
Well, if I'm not mistaken, I think the next talk is going to talk about this, right?
No, not quite
No?
that.
Okay. Okay. So maybe you have the answer, Ben.
Okay, I've got my opinion. So Ben, work online. I've certainly got an opinion on this. I think it's a false choice, to be honest. I've told you that in private. I think that the number of places where it makes sense to do origin validation in the network in the first place, given the number of routes that you're likely to be dropping, the additional memory consumption that's going to be required on any device that's in that kind of a role in order to keep the whole of the adjacency rib in is actually mostly meaninglessly small. And so actually I think this is a really easy choice for people to make. There may be some operators for whom there's a big trade-off to be made, and I think in those cases, look, consenting adults can do what they want, right? I mean, you know, we don't need to speak, you know, if we agree to revert to BGP3, then we can do that. There's nothing that can stop us doing that. But I think in the general case, the guidance has got to be, don't be antisocial at your local internet exchange. And sending a route refresh, whether it's every 10 minutes or every hour, it's pretty antisocial. I also had a question for Amreesh. Okay. I was a bit confused by your timing matrix slide. There were two things that stuck out. The first was, yeah, that's the one. So the first was that I would have thought that your expectation would be that those timer numbers would be additive, at least in the worst case, right? If the relying party is refreshing every 10 minutes and the router is refreshing every 5 minutes, then 10 minutes is your best case, right? Your median case is, you know, is 12-ish something.
Yeah, you're absolutely right. This is the best case scenario,
Okay.
not the worst case scenario.
Okay,
Yeah,
cool.
yeah.
So I just wanted to check I was reading
Yeah.
that because I found it confusing.
Yeah.
The second thing is I think maybe you were testing with an old version of RPKI client because RRDP support has been added a while back now. And also it runs in the cron, so it doesn't really have like a default timer.
Yeah.
You've got to pick one.
Yeah. Indeed, yeah. RPKI client doesn't have a default. It runs using a cron, yeah.
The measurements you did, were you observing just the point at which the route appeared or disappeared at the border of 1239 or 2914, or were you looking more widely at receiving ASs?
So for this experiment, so we were looking at just the two, entity and sprint. I think we look at there's Dutch Telecom as well, if I'm not mistaken.
Okay.
Yeah, the numbers are more or less the same. So our own network, our own AS from which we were advertising these prefixes was not doing ROV, so we were relying on the upstream doing the ROV.
Yeah, that makes sense.
Yeah.
Does Sprint do ROV? I must have missed that announcement.
I think so. Yes.
Okay.
Yeah.
Because I think an interesting experiment to follow on from this, because I think this is really useful information, because no one's really, a lot of people have looked at the theoretical timers, but no one's really looked at the real world behavior. I think a more interesting question actually is not when does the route come and go if you are, if you're a stub hanging off networks that do ROV, but if your transit doesn't do ROV, how long is the wider propagation time when you're, 3, 4, 5 hops away from the receiving AS? I'd be, if you've got the cycles, I'd be really interested to see those results.
So right now we don't, but this is a very valid point. So this is something we could add to this experiment. So we want actually to expand this experiment that was more operators, because right now we are just using 2.
Sparkle.
Yeah. Okay. Point taken.
Amreesh, is this an ongoing experiment or was it a batch?
This one is still ongoing. Still ongoing. Yeah.
So people could add things into it,
Yeah.
either endpoints or
Yeah.
new tests.
New test. Yeah.
Is that you volunteering for?
If you want to, yeah.
Send
if you
him email.
want- Yeah. Sure.
Mark,
Thanks. I think just to answer,
who are you?
Mark Tinker SAFNOG. Just to answer, I think Andrew's question on the route refresh debacle. Yeah, and Ben's right. Holding adjacency rib in, wholesale should be technically a minuscule task today. Having said that, though, I do know some people still run MX80s or MX104s or things of that nature that would break. And I think ASR 9001s type thing are also around. No, that's exactly. No, but there's a bit of memory issue in some of those, especially during churn. We dumped 15 of them out of the network for that reason, so I know. So that's the one reason. Yeah, that's the one reason. There's no money to buy stuff for that reason. Just turning off ROV is just simpler for some people. The other one is it gets done for you. So like in our case, an ASR 9K, the peer, I think it was DKIX, did it for us and shut down the session and said, go fix it. And that's how this RFC draft came about. So those are the real practical, considerations that one would have to make from those two standpoints.
Yep. I have nothing to add on that. Any more questions from the room?
We only mention it because lunch is in 4 minutes, so we're running a little late. Okay. Thank you very much, Amreesh.